about ready to embark on this first set of breakout groups, and the way we'd originally kind of thought about it was that since the 4 new candidate components for these Earth system type models going into AOGCMS kind of naturally fell to the 4 people that gave the overview talks, that would just evolve into 4 working groups that would actually kind of fill in the gaps and try to kind of look at these, wait a minute. Yeah, for these questions here. So we got the right list. But in discussing it, it may make more sense to actually combine carbon cycle and dynamic vegetation into one breakout group and aerosols and chemistry into another breakout group. Because those 2 are pretty closely related, and we kind of have a small group anyway, so you may get better discussions going if there was actually 2 breakout groups. So if we do that, then we'd originally identified Peter Cox and we had Cox and Hurt as the leaders, and Kicklighter and Lawrence as the kind of helpers to take notes and try to put things together. So maybe those 4 people could kind of organize that that conjunction between carbon cycle and dynamic vegetation. So, so Peter Cox and George Hurt would be the kind of the co-leaders, and then the 2 days, Dave Kicklighter and Lawrence would decide kind of how to, so you can self-organize. So then the other group then would be Phil Rash and Jean-Francois, and Claire and Olivier would be the 2 kind of transcribers, or however you want to do that. So that sound okay?
Yeah.
Okay. And so the idea is we put together this kind of list, which you've got in front of you. And these are just questions to kind of guide your discussion to, and the idea is this is all going to feed into this white paper we're going to write. So this is the part of the white paper where we'll really talk about what the state of the art is now with these components, what's ready to go in 6 months, 2 years, or 5 years. So kind of, how this is kind of staging out. So what you really think you'd like to see going into AOGCMS and Earth system type model, really in the near term, kind of medium term, and then longer term. And maybe other questions could be, does it need to be continuously coupled, or can you maybe run it offline and occasionally couple it in? And there was this idea yesterday that Guy had, that maybe the chemistry component that could work for that the chemistry may only need to be coupled once every 10 or 20 years. Jean-Francois is kind of smiling about that. But anyway, so this is a question. You can consider this, dismiss it, or maybe advocate it, whatever. The time scales of the climate feedbacks. So if you think that you're looking at climate change over the next 10 years, maybe carbon cycle wouldn't have that big an effect on the feedbacks, the size of the feedbacks. Or maybe dynamic vegetation dying or growing in a place would really have a big feedback on a shorter time scale. But maybe some of these feedbacks would be longer, maybe 10 to 30-year time scale or 100 years. So when you're going way out, like into the 21st century, maybe the feedback involved with one of these components would dramatically affect the answer. And that, like the carbon cycle results seem to show that, when you get out 100 years, it really makes a difference whether you have the carbon cycle in the model or not.
You're also going to consider stabilization in that context.
You can if you like.
Which is, infinite timescale.
Yeah. Depends on how you want to do it. So it's the idea is, this time scale of the feedbacks is kind of the idea. And this idea of whether the feedbacks are global or regional. So if there's a global feedback, you could maybe scale some pattern of climate change just by the strength of the global feedback. And you wouldn't need to know regional information. But maybe for things like land use, for example, regional is where it's all happening, and maybe that's important. So that's another kind of concept, this kind of what's the space scale of the feedback. And then the computer resource question's another one. If you add in a really complicated chemistry component, is that just going to kill the model and you're not going to be able to run it? Is there a way to get around that, or is there a way you think that computer resources will be able to handle that? So that's kind of a computer resource question. And then now, if this component was coupled, what requirements would you need from emission scenarios? In other words, what time series of what constituent emissions would you need to be able to have this component coupled into an AOGCM? And then the last one is, okay, maybe you decide this particular component isn't quite ready. Well, what do you need? What are the missing pieces? Do you need some key observations to really pin this down? Or is certain parameterizations a problem? So, if you think maybe this component should go in 2 years from now, like what's the roadblocks, or what are the barricades you're encountering? And then kind of what's the time frame for really making those improvements and getting into the model. So those are just kind of, and this is not a total list by any means. These are the types of things you may want to address when you're discussing these things in your breakout groups.
Okay. Jerry, can you say a little bit more about the white paper in terms of the audience?
The audience initially will be us, our communities. So what we really want to do, in particular for WGCM and AIMS, we want to make sure that we address, because the idea is this white paper initially would be input for the WGCM AIMS meeting in September. And so it should be at that level of technical detail and really dealing with the issues that we think we're interested in and need to be dealt with. That could be used then as a basis for maybe either an EOS paper or BAMS or something like that. So we'd probably want to decide that kind of after we get it put together. Or we could decide it in September too when we have the WGCM AIMS meeting. So I think initially it's going to be for our communities. We're going to be talking to our communities and how these scenarios feed into this. And we just saw from Naki's talk, the scenario part of this is really an integral part. And we started going through little exercises like this, saying, okay, what kind of model would you need to look at these types of scenarios, and how many runs would it take, and with what model? And we're going to get into that a little bit more. The next breakout groups are going to be talking about actual experimental design. But these breakout groups are really just talking about the components and how they would go into the model. So you may keep in the back of your mind that we're going to be talking about experimental design and exactly how you'd use these models with what scenarios on what time scale. That's for, I guess, Thursday. So does that seem reasonable to everybody?
And the emphasis is on the simulation of the climate.
Right.
Should it be?
Well, I mean, that's my question.
Yeah.
I mean, because should that component be in there, will it be dependent
That's right.
on what you want to do with it?
These are, the idea is we're going to be using these Earth system type models to do future climate change projections that are of interest to policymakers.
No, you talked about we're going to defer the discussion of experimental design until the next breakout sessions. But, for example, one of the things which has been taking place over coffee are conversations about, for example, the need or importance, how to do the problem of reproducing the historical record correctly, and its importance for what we do for the future scenarios also.
Yeah.
Do we want to do? Does that go into this breakout group, or does that go into the
That'd
next?
probably go into the next one.
Okay.
I mean, and we're not drawing a hard line.
Right.
I mean, some of these experimental design issues are probably going to come up, and you can talk about them certainly. But I think for this kind of part of this, it should focus more on the components themselves and their readiness and their capabilities and how they would actually go into a Earth system type model that would be used for these climate change projections.
Shouldn't we actually broaden question 3 a bit? Why we need a component? And that can be because of the climate feedback. That can be because
That's fine.
of the impacts.
And again, these questions are just to guide you. This is not like a questionnaire. You don't have to fill in the blank kind of thing. These are just to kind of guide as you discuss things and to get you started talking about things. And then you can, of course, address any aspect of these things you'd like.
How long are we going to go here?
Okay, so today,
Today, just today.
till late tonight. No, today we have break for the day at 5. So, but I'd say probably go to 5:15. So if you spend a next hour kind of getting going, and then tomorrow morning you kind of reconvene for an hour and a half, and then at 10:30, we'll have these. One right before lunch and one right after lunch will be reports of these two working groups or breakout groups. Sound okay? And of course you can go. This is flexible, so you can go as long as you want. But that's probably the general guidance. Okay, does that sound okay to everybody? So I guess one group could stay in here, right, John, and the other one could maybe sit over there. Or,
yeah, that's good.
Okay.
So we're just dividing it into groups?
Yeah.
And how are we supposed to do that?
You can decide which group you'd like to affiliate with, unless we think. One is carbon cycle, dynamic veg. The other one is aerosols and chemistry.
Which group is where?
Okay, so let's have chemistry's here, and carbon cycle over there.
Interesting choice.
I was just influenced heavily by somebody in the front row.
Sounds okay to me.
It's all right, the carbon group is already on their way over.
Yeah, they're already leaving.
Whose presentation?